James Bach is a consulting software tester who runs his own consulting company called Satisfies Incorporated. He has been a software tester for 34 years, started in 1987 at Apple. His two passions are education and testing. He's the author of two books, Lessons Learned in Software Testing and Secrets of a Buccaneer Scholar. One focused on testing and the other one focused on self-education. James Bach is a warrior, the kind of warrior who fights with all his being for the cause he believes in. That cause is professional testing. The attitude, weapons, tactics he has chosen are courses, blogs, talks, writing books, coaching, helping and giving interviews whenever he finds people interested in learning more. James believes that excellent testing is a craft that requires many skills, ongoing practice and focus to develop and maintain those skills. The skills of testing include general system analysis, critical thinking, mathematics, but also social skills. This is the second time James joins AgileHub, so please welcome James Bach. Hello.
Hi, thank you. Nice introduction. I didn't write that. I don't think I wrote that. Anyway, so that's exciting. Something. I will live up to this. The warrior tester is here.
I could send you this text if you want and use it whenever when you go shopping.
All right. Okay, folks, let me get going. So so I want to talk about hypotheses because they are fundamental to really professional test design for those of us who are really serious about our testing. Let me get right into it because I don't have a whole lot of time. This is what I mean by a hypothesis. I've adapted these definitions from the Oxford English Dictionary. A possible state of things considered as a basis for action is a very general idea of hypothesis. A more specific scientific idea of hypothesis is a conjecture meant to explain some facts that you see, and then that guides further investigation. So that means it's pretty fundamental to testing to work with hypotheses. So here's an example of the first thing. If you say, hey, the product might have bugs, well, I guess we better test it. Well, that's a very high level kind of hypothesis. Or if more specifically, you're investigating a problem and you say, well, the failure only happens at night. Why would it only happen at night? Maybe there's a server going down for maintenance. Let's check with the ops people about that. Let's look at the logs about that. Then that's another form of hypothesizing and then following on that hypothesis to do an investigation. I was trying to think of a picture that would represent hypotheses, and I did a Google search, and they're all terrible. No one has any ideas. So I finally came up with shadows. Shadows is a nice little way to get across the idea of hypothesis, because a shadow is an observed fact. You see the shadow. If you don't see the thing casting the shadow, then you can guess from the shadow, oh, it must be a goose behind a flashlight. But no, it's actually somebody's hand. So the hypothesis is, I suspect that this is a shadow caused by somebody's hand. A hypothesis connects the actual cause of things to the facts that you witness. And we can apply that to testing. We can say that the product behavior that we are observing with our tests connects us to the actual quality of the product. You don't actually ever see quality. The product behaves well, but you never know what its real quality is. It's the same thing with people, isn't it? Especially if you're dating somebody and it's your first date. They might behave well, but anyone can behave well for one date. Maybe after that, they become an abusive, controlling, jealous partner. You don't know. You're gathering information. My wife married me after 2 dates. She was very wrong to do that. Someone should have stopped her. But I needn't tell you, she's not a tester, not like me. I had been married before. That's called testing the previous technology. And so I knew what I was getting into, but she did not. She should have waited. We've been married 30 years now, though, so I guess she guessed right. Now, I just said something earlier that was not true. I said that the test design starting line is the hypothesis, but it isn't. The test design starting line is not the hypothesis. It is the starting line comes well before the hypothesis. When I was naming this talk, I got interested in hypotheses and I wanted to talk about them. So I was thinking in my mind of what happens after you have an hypothesis. But then when I did all my research and really got clear about what I'm talking about, I realized how wrong I was. But then it was too late to change the title of the talk. So I'm changing it right now. It's the test design middle line, which doesn't sound as good. What is the real starting point? How about when we are born? That's the real starting point. There's fascinating research about the scientific thinking of children, and especially of babies. Babies have born human babies, but also actually many animals, higher animals, are born with the equipment all ready to investigate the world. And then we are born with a compulsion to investigate it. And they did some experiments with babies where they fooled the babies. They did things with physical objects that defy physical laws, which apparently, babies aren't supposed to know about physics. It turns out every baby has an inbuilt model of physics in its mind. And when you violate physics, the baby will play with that toy in a way to experiment with the violations that the baby saw. So an 11-month-old infant more likely to learn a new sound associated with an object if the object previously violated the infant's expectations. And they play with toys in a way that reflects the expectations that they saw violated. So if they see something that seems to have no solidity to it, they'll bang it and see that it does have solidity. They drop objects that looked like they were floating before. It's quite fascinating. So we are long before we ever have hypotheses. What we're doing is we're building mental models. Hypotheses come from our mental models. This is very important because when you design tests, you always design them based on all of your background knowledge. You don't start ever with zero knowledge. All right, but they are the start of a particular kind of systematic test design. So here's my hypothesis space, as researchers call it, and here's the product space. Now, when researchers talk about this, instead of product space, they call it the experiment space. But for us, because we're testing products, this is the product space, is the experiment space. So the product space is full of facts about your product. And the hypothesis space is full of theories, where you say, I think the product is a good product, or I think it's a bad product, or I think it's behaving this way for this reason or for that reason. Now, research shows something quite interesting. If you take people and you give them something to investigate, some people will have a little bit of experience. They'll do a little thing with the toy or whatever you're having them experience, and then they will come up with an explanation. And then they will try that hypothesis out by doing a little more testing, a little more work. And then they go back to hypothesizing. Other people do a lot of interaction and they postpone their conclusions. And it's just a matter of temperament. Some of us like to gather more data. Some of us like to be more theoretical and theorize from less data. And there's no right or wrong here. It's just interesting that there's different temperaments. But what there also is there are specific kinds of testing which are hypothesis oriented. So if you do requirements-based testing, you are driving your testing with hypotheses, because every requirement, if you're going to test it, you're saying, my hypothesis is the product violates this requirement. Now I'm going to go get evidence that it violates this requirement. Or perhaps the way you think about it is you say, my hypothesis is the product fulfills the requirement, and then you go seek evidence against that hypothesis. Either way, if you want to test very sharply, you should be testing in a way that's looking for problems rather than looking for goodness. So requirements-based testing is hypothesis-oriented. Risk-based testing is, sanity testing is, because what sanity testing is you're saying, I hypothesize that this thing is insane. It's broken in fundamental ways. And now I'm going to look for data to prove that it's just broken, it's totally broken. Bug investigation is also very hypothesis-driven, because as soon as you notice a bug, you say, what's really going on here? I see this behavior. This is weird behavior. Maybe it's because of this. Maybe it's because of that. Just last night, I'm debugging something with Michael Bolton, a program we wrote to pull messages off of Mattermost, and we're getting this error that looks like it comes from the fact that an image has no name. Why wouldn't an image have a name? And Michael hypothesized it's because it was a deleted image, and that erases the name of the image. And we tested that hypothesis. It turned out it fit our evidence perfectly. He just guessed what it was. It was our first guess. And then we went ahead and fixed the bug and stopped our program from trying to process deleted images, which was the root issue. So some kinds of testing are hypothesis oriented, driven by hypotheses. You then collect the facts you need to understand if the status of those hypotheses. But there's other kinds of testing that are fact driven, where you operate in the product space. For instance, two kinds of testing you probably haven't heard of unless you've taken my classes. Survey testing means testing specifically for the purpose of learning about the product, not primarily for the purpose of finding bugs. But if you find bugs, then you report them. We call that survey testing. Analysis testing is testing primarily for the purposes of getting yourself organized so that you can do deep testing. So with analysis testing, you're making lists and models of the product, and you're also stumbling into bugs as you're doing that. Scenario testing is something that you may have heard of, is testing based on interesting, complex user scenarios. There's no hypothesis involved. It just says, try this kind of thing with the product. See what happens. See if there's any failures. Same thing with tour-based testing. A tour-based testing just means you go on a certain tour of the product. You tour the user interface. You tour the complex areas of the product. You tour all the kinds of data that you can give it. There's various ways that we can imagine touring the product, but there's no particular hypotheses that are involved with that. It's just gathering facts. And then that triggers new hypotheses as you go through the facts. So for requirements-based testing, what your hypothesis looks like this. Does the product violate this requirement? I hypothesize that it does or that it does not. for risk-based testing, does this kind of problem exist in the product? You conceive of a problem, you think it's likely to exist in the product, and then you go looking for evidence that it does exist or that it does not exist. Same with sanity testing, bug investigation, very hypothesis oriented. Whereas these other ones are scanning for data in the product space. Now, there are things that go wrong with this. You got to watch out for them, especially if you're really into automation. Now, I am frequently falsely accused of not liking automation, which is very strange because I'm a developer. I have been a developer before I was a tester. I started testing in 1987, but I was a video game developer for 4 years before that, in my teens. And when Apple hired me, they hired me into a developer tools group. So for 8 years at Apple and then later in the Borland C++ group, I tested developer tools. All the testers who worked for me were programmers with computer science degrees. We were all coders. So I'm a very coding-oriented guy. So when I criticize automation, it's not because I don't like automation. It's because that automation doesn't work. It doesn't help me find bugs. That's why I criticize automation. So I'm really careful because I've been victimized by this even in my own work when I've written my own automation. What's going on here, the thing I'm warning you about is sample bias. Sample bias comes in when you decide you're going to use a certain tool like BDD, for instance, or TDD or Selenium or a particular instrumentation method. And you're going to use that to collect information about the product. But the method that you choose discourages you from collecting certain kinds of information because it's hard to collect that information. So it always bugs me, these BDD given, when, then statements. They always strike me as so simplistic. They discourage you from saying anything complex. So if a tester has a nice complex idea for a test, well, don't come to BDD. It doesn't like that. There are people who say, well, best practice for test automation is you should not make a test that takes more than 5 minutes to run. Right. Well, I've created tests that take 48 hours to run, and they were good tests, and they found things that would not have been found otherwise. Of course, they were stress tests. So be careful. Any tool that you use in the instrument space is filtering what you see from the product. Experiential testing is what most of you call manual testing. I will call it experiential testing because I'm not trying to emphasize my fingers. Manual testing is about fingers. Experiential testing is about your mind and your senses. I need to experience the product that the end user will experience. I need to see what they will see. I also use automation, yes, but I don't let that automation dissuade me from experiential testing. So just watch out because you're going to suffer then from what's called sampling bias. You can look that up on Wikipedia. So people often ignore test ideas or test results that don't fit with their tools. Beware of that. Here's another problem. It's called the ostrich effect. You can look at this up on Wikipedia as well. The issue here is when you don't want any bad news, you pick a happy hypothesis. Oh, I'm sure everything's fine. And then you collect the minimum number of facts to justify that, which is called confirmation bias. But the ostrich effect is confirmation bias, but also with an extra idea, which is you're always focused on the positive. This is how I tested when I was a video game developer. I hated testing when I was a developer, back when I was a teenage developer, that is. I'm a professional now. I'm a full-grown adult. But when I was a teenager and I was writing my video games, the last thing I wanted to do was test. And I did the minimum possible testing I could get away with before we shipped the product to the customer. And then once in a while, they found bugs in my stuff. And I'm like, oh, well, you know, it's going to have bugs, whatever. So watch out for the ostrich effect. And that's what you get when you think positively instead of aggressively and critically and negatively. As a tester, I believe in trouble. I want to see trouble. I don't want someone to talk me into how great quality is. You know what? Quality is great. It's so great that literally everybody else on the project except the tester should be thinking about quality. What the tester should be thinking about is trouble, problems, strife, pestilence. You might say, why do we even need hypotheses? We can just collect the facts. Just the facts matter. And that's a good point, except there are too many facts. There's too much about the product for us to find out. So we can't find out everything. So we do need to filter it. And that's what hypotheses do for us. So we don't want to over-filter by having the ostrich effect, but we do need to filter and focus. And that's what risk-based testing is all about. So risk-based testing works like this. You have a conjecture about risk, you focus your testing, then you see what really happens. This then is in a loop where you can do better risk analysis. I can give you a little more information here. I identify my suspected risks, and then I focus my testing by mapping them to the suspected risks. I say, if I have this suspected risk, what testing do I have to do to understand if this suspected risk is a real risk? And to give you even more detail, I can do white box analysis. My understanding of the code can help me with this. I could do black box analysis, looking at external characteristics of the system. I group and sort those into areas to simplify things. And then for every area, I say, what part of the product do I need to spend more time with? What kinds of problems do I need to look for and design my tests to find those problems? And is there any way I can make the product more testable so I can do that more easily? Once I do those things, then one of four things is going to happen. Maybe more, maybe all these things are going to happen. If I don't find any trouble, then I either decide, well, that's because I didn't test deeply enough, test more deeply. Or if it's not important enough, I just stop testing and say we're done. If I find exactly the problem that I expect to find, that corroborates my notion that, yeah, that's a real risk. I thought there would be a problem here, and there was. I might stumble into problems that I wasn't expecting. And if so, a new risk comes into my head, a new hypothesis. Maybe there's more failures of this kind. That's the hypothesis that comes into my head. And then I focus my testing on that. Or maybe I do all this testing, I focus on the risks, but I'm focusing on the wrong risks, it turns out. And problems get by me because I didn't find them in my testing. Well, eventually I'll find out about that. And if they matter, if those problems are important problems, well, then that becomes a risk. And then I can consciously and intentionally test for that kind of thing. So that's the idea. Now, let me give you an example. Last week, I was involved in a testing contest. And one of the things, I was actually judging the testing contest. And I thought that I should test the product before I judged the 16 teams that provided their final report. And one thing I noticed is that none of the teams that competed used any significant kind of automation. So I thought, I'll make sure that I use automation to kind of demonstrate to these folks a way that they could have tested the product. So I had a little bias toward automation as I was testing. So it's an online library of books called Libri. And while I was testing this, I was clicking around in an experiential manner, trying to understand the experience of using the product. As I did so, I noticed there's a lot of books. I wondered how many books. Through a few experiments, I learned that there's about 2,500 books on this system. This system that lets you read these books online. Well, if there's 2,500 books, from what I know about databases and such, any one of those books could have an incorrect data entry, the wrong title, the wrong cover. So I'm starting to think, how am I going to cover this product space? So this is the beginnings of a hypothesis. I see this and I think, well, as soon as you have a lot of data, then you can have data corruption. The data corruption can hide in the data. How am I going to discover that? So I'm going down and clicking on different books just to get a feel for it. So I'm still in the product space, right? And I did a search for the word science and 3 books pop up. And I click on the middle one and I get this. I get a 500 error with a really ugly page-long, actually a 2-page error message. This is probably a security risk, apart from being just ugly and useless. So immediately I had an idea. A hypothesis sprung into my mind. This is not the only book that is corrupted. There's got to be others. I mean, what are the chances that I would just click on a book that just happened to be corrupted? There must be half the books in this database are corrupted. If I just stumble into literally the first book that I clicked on and boom, 500 error. So I decided to collect all the status codes from going to every single one of 2,500 book pages. Now, if you're testing purely experientially, that's going to be a lot of work. So that's when I pull out the automation. So I used a Perl library called Mechanize. There are obviously equivalent libraries in Python and in other kinds of tools, but Perl is the language I'm most comfortable with, so I tend to use that. So I basically put it into a loop and went to every one of the book pages from 1 to 2,500 because it conveniently, they're just numbered. So I just went through, bang, 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 pulled down the URI, got the status code. While I was at it, I saved the page. And then later on, I did other kinds of analysis of those pages and found other kinds of bugs. But the first thing I did is just did that. And then when I grepped the log that I made, it turns out 2 of the books, book number 597 and book 2167, give me 500 errors. 2167 was the first book that I clicked on, that science book. So it turns out there was something like a 1 in 1,200 chance that I just stumble into a 500 error. There are very few 500 errors. So I just got really lucky, it turns out. And I know that because I tried every single one of those. So final thought on this before I go to questions. My final suggestion is if you want to get better at doing testing in a professional, intentional, systematic way where you look and sound like an expert, practice putting your hypotheses into words. Say what the hypothesis is that lies behind any test that you are attempting. And there might not be a hypothesis. It might be very general. Your hypothesis may be, I think there may be a problem in this part of the product. That's when you're focusing on the product space. But there may be a very specific hypothesis that you are pursuing if you're doing requirements-based or risk-based testing especially. So what is that hypothesis? Practice saying it. As you practice, you will get better and better at this, and then you will sound more and more like an expert tester. It will clarify your practice and sharpen your mind. All right, well, I'm ready for questions if you have any.
Thank you very much, James. Really thoughtful speech. And we have 3 questions for you if you still have some time.
Sure, yeah.
The first question is, if BDD is not the proper way to describe a complex test case, what do you recommend?
I recommend talking with your voice in normal language, using ordinary sentences. What BDD, the given, when, then thing, is an artificially dumbed down way of communicating. I don't understand. We're supposed to be smart people. Why are you giving me a stupid way to talk, Dan North? You know, because I know why. It's because you're trying to make it easy for your tools. Well, my testing is not going to be something that I'm going to make easy for my tools. My testing has to be complex because I got a complex mind and those bugs in there are elusive and I'm a serious tester. BDD is, it seems to me you talk like a baby. Given, when, then. It's too simplistic. I know it looks all scientific, but it's too simplistic. So I can't stand it, as a matter of fact. Can't stand it. Just use regular language. That's what I recommend. Have ordinary conversations.
The next question is it true that you don't believe in best practices? And yes, and if yes, why?
Well, there's no such thing as a best practice. The whole idea of a best practice was invented by marketers. And unless this is a marketing conference, it has no place here. There's no such thing as a best practice. The only people who use the phrase best practice are very insecure people. Try this. The next time you want to say this is a best practice, try this. Just don't say the word best. Just say this is a practice. If you really want to, say this is my favorite practice, or this is a practice that I'm excited about. Now, the first instance, if you just say this is a practice, nobody is going to come back to you and say, wait a minute, Nadia, Marius, is this a best practice? Or are you just telling me about a random practice? No one is going to say that because they assume that the only reason you're talking about a practice is that you think it's good. And if you thought it was bad, you would say, I don't like this practice. It's a bad practice. So you don't need to say best because for one thing, it's not true. You don't know what the best practices are. There are no world championships of practices. There's no Olympics of practice. No one who ever named something a best practice submitted it to a body of learned wizards who then waved their magic Orthink Palantir stones over it and pronounced that the gods have said it's best. No, all it is some guy's opinion. And here's the thing. I'm here to tell you, as a 55-year-old, extremely opinionated man, that just because somebody like me says they like a practice doesn't mean it has to be your best practice. Finally, think about what someone's motive is when they say this is a best practice. Really think about it. I think I know what their motives are. If I were to say this is a best practice, Marius, I'd really be saying, shut up, Marius, and do what you're told. I know what the best is. And if you disagree with me, I guess you're not the best. Not like me. I only do best things. It's a weird intimidation tactic, and it's completely unnecessary. So in 1999, I started something with Kem Kaner and a couple other guys called context-driven methodology. We said, let's just let's just say there are no best practices. And what we're going to do is we're going to say every practice relates to its context. So a practice can be good or bad in context. And we develop the skills and we develop the arguments and the evidence to argue that a particular practice is worth doing here, but maybe not worth doing over there. That's what adults do. Adults understand. Adult humans in every other field understand that there's some things you can do, and some of them are better and some of them are worse, but depending on the situation, that's going to be different. And we just need to operate if we're going to be full adults, I claim. We need to start operating in the space of relativity.
Great answers. One more question from Christy is, why is that some people can come up with more and better hypotheses than others?
A couple of reasons. One is motivation. If you're really excited and motivated and you feel that your ideas matter and people listen to you, then you're always going to come up with more ideas. If you feel that nobody listens to you, your ideas don't matter. And this might be because you were raised that way. You know, I agree that I have a certain privilege. I grew up privileged because my mother and my father always treated me as if I was going to be an important scientist someday. So I started believing it. And I believed that my ideas and thoughts were important because my family was constantly telling me that my ideas and thoughts were important. I never got any other message when I was growing up other than, you're going to be an important person someday, James. And I realized that lots of people, especially people of certain other genders than mine, are often told other things than that. They're often given discouraging messages that say, we really aren't interested in what you say. We just care about how you look. And I didn't get those messages growing up. So I barged into Apple Computer assuming that everybody cared about what I think. Whether it was true or not, I don't know, but it was certainly my idea. So I was very motivated to come out with ideas. But you know what? After 4 years at Apple Computer, I lost my morale. I got discouraged because I felt like management didn't care about testing and about what I was doing. So I stopped coming up with ideas, and I got really depressed and burned out. And I got married, and that reinvigorated me. And then I went to a new company, Borland, and they really wanted to hear what I had to say. And suddenly I had lots of ideas again. So one thing is motivation. Another thing is you need rich mental models. You need to read widely. You need to be curious about the world. One suggestion I have that is my secret weapon and can be your secret weapon too, is read the Hacker News feed from the Y Combinator site. Hacker News is the single best aggregation of incredibly interesting and incredibly widely varied scientific, technical, software news. So that's my one-stop shop. I go through a bunch of articles from that feed every day. And that gives me rich ideas and mental models, and then I can have better ideas.
Do you still have time?
Oh, yeah, I do.
Alex is asking, he has several questions. Well, I'll start with the first one. Is there such thing as too much testing? How do you convince the PO that testing actually makes the product better?
Well, the testing never makes the product better. That's a complete misunderstanding of what testing is about. Testing makes the product better only in the sense that if you're driving a car that's totally stationary, staring out the windshield gets you to your destination. Well, it doesn't get you anywhere. The testing is the headlights of the project. It casts light into the darkness. So is there such a thing as too much testing? Well, of course. Imagine that you had a giant spotlight on your car. Imagine you had 16 spotlights in some sort of girder arrangement, blasting light so that you could see a mile and a half down the road. Well, you're wasting energy. You don't need to see a mile and a half down the road in order to make your business decisions. Yes, there's such a thing as too much testing. And actually, I almost made a slide about it. It's when you get really obsessed with facts and you feel like you always want more information. You always want more information and you never want to release. And this is a big problem for serious testers. We tend to feel that there's always something more that we should know about the product, and we're nervous that we've missed something. Really serious testers are nervous that they've missed something. And one of the things that we need to learn to do is let go, is to say, I can never guarantee that I found every bug, but I can promise this. I promise everyone around me, I will learn from whatever bugs that I missed. I don't guarantee I'll find everything, but I do guarantee I will learn from every bug that I do not find that someday somebody else finds, whether it's the user, whether it's another tester. I think I should find every single bug. I know I won't. I know I have to stop at some point, but I console myself by saying that the best I can do is to let go at a certain point and learn from what happens next. So it's hard to know exactly when to stop. It's one of the things I teach in my classes. It's a lengthy lecture that I do on that. But yes, it's possible to test too much, and no amount of testing makes the product better at all. Remember this, my fellow testers. The people who make the product good are developers and the managers that give developers the environment to get their work done. Those are the people who assure quality. Those are the people who create quality. I never say that I create quality, or I don't even say I'm a quality specialist. I say I'm a tester. My job is to find out the truth. That's what I'm good at. Find out the true status of the product. I shine light into the darkness so that other people can get their work done. I love questions. Keep them coming if you have any.
Do you believe in a muse of hypotheses or ideas of some sort, or the whole phenomenon can be fully reasonable explained?
Can you read that again?
Do you believe in a muse of hypotheses or ideas of some sort, or the whole phenomenon can be fully reasonable explained?
I don't understand what the words are that you're using for the first part of that. A muse?
Do you believe in a muse?
A muse? Like
Yes.
daughters of Zeus? Like Calliope? Calliope, the muse of testers?
Yes.
Well, of course I do. In fact, I would say that Ask the Testing Muse is the single most popular test technique out there. I think most people, when they come up with a test idea, here's how they do it. They say, oh, Calliope, daughter of Zeus, muse of software testers, give me a test idea. But you know, Calliope is a very lazy muse, it turns out. And she always says the same thing. She says, try the boundaries. Try the boundaries, idiot. You know, that's what she usually says. So what you got to do to get better service from the Muse of Testers is you need to give the Muse of Testers a few suggestions. So what I do is I use guide word heuristics. So the heuristic test strategy model, which I teach in my class, is a set of words that are they're called generative heuristics. You say the word and then you say it to the muse, and then you wait for the muse to give you a test idea. Here's an example. I have on my list something that says startup shutdown. So when I see startup shutdown, I think, okay, Muse of Testers, startup shutdown. And then the testing muse gives me an idea about testing every way I can start the product and every way I can stop the product. How do we start and stop the product? Do I need to explicitly log in? Do I have to log out? Am I automatically logged out after a certain period of time? Does the system go down for maintenance? What happens when that happens? All these ideas start tripping in my mind, but it starts with this little seed, startup shutdown. And I put that on my list after I missed a bug once that only happened when you started the product in a certain way. And I said, I don't want, the testing muse didn't give me an idea about testing that. So I'm gonna give her some help. So I added that to my little checklist of ideas. Now you can maintain your own personal, private set of guide words that when you run your eyes down these guide words and give yourself just 30 seconds to think about them, maybe the Muse of Testing will just drop an idea. And that's how it really feels like, because your intuition, your wordless unconscious, bubbles up ideas all the time. And another thing I do that I learned to do after 10 years of being a tester is I learned to listen to people who were not good testers. I learned to listen to people who are novice testers. I learned that anyone at all can give me an idea that even if they don't know it's a good idea, I can make useful work out of that idea. So it's weird because until I was about 10 years into testing, I thought that I could only learn testing from people who knew more about it than I did. But that's not true. You can learn about testing from people who don't know anything about testing, who never read a testing book, just by watching how they test and asking yourself, I wonder where he got that idea from. Why didn't I have that idea? And that starts a whole analysis process where you end up inventing a test technique. And the novice tester whose behavior caused you to invent a new test technique has no idea that you just learned something about testing by watching him do something. But I have this experience over and over and over again with people in my classes who come up with clever ideas. So I would say there is a muse of software testing, and the muse gives me hypotheses. Muse gives me all kinds of ideas.
You'd love this question. You said that your wife made a mistake when she married the tester. Why is that?
Well, if you let me put it this way. In 1999, I was so angry with my employer. I'm working for 6 months for a place called Reliable Software Technologies, which no longer exists. But I was so angry with them. They asked me to do something I felt was unethical. So I just told them I quit. And I went home to my wife. Now, I'm the sole breadwinner in my family. I had a small child. My wife was a full-time homemaker. I had just bought a house. I had just bought a car. And I got a $30,000 sign-on bonus, but only if I stayed for 2 years. So I had to pay back $30,000 that I didn't have. And I couldn't pay my mortgage. My wife, who is not a critical thinker at all, her reaction to this was, everything will be all right. The angels will save us. That's the kind of person to marry. Not someone like me who's going to say, this is a disaster. Think of all that can go wrong. I've had 2 panic attacks in my life. One, I was lost at the age of 12 in the woods in Vermont. And it was before I took any of the classes to learn how to survive in the wilderness. And the second time was the day I quit that job. My wife is saying, it's going to be okay. I'm feeling dizzy. I can't speak properly. I have to lie down. That's only the only other time in my life that I've had a panic attack was that. And my wife called my brothers and sisters and and they immediately lent me a bunch of money, and then my best friend bought me a computer because I actually didn't own my own computer. My company owned it, and I had to turn it in. And then Microsoft called out of the blue the next week and offered me a huge contract because they heard that I was available. And I had no idea that I was that well known, that people would just hear I'm available and immediately offer me a check for $20,000, which is what the guy gave me. I said, I need money right now. And he said, how about this? And he just gave me $20,000, which, by the way, almost never happens when you get a consulting assignment. So my wife says a week later, see, I told you the angels, they just fix everything. That's the kind of person you want to be with. And that's not the tester mentality. That's the entrepreneurial product owner, scrum master mentality. Marry a scrum master, for crying out loud. Don't marry someone like me. But I don't know. She saw something in me that I'm grateful that she saw. And also, I don't behave this way around her. I never test when I'm at home. I never act like a tester when I'm at home. There's a rule after the salad dressing incident of 1991. I am not allowed to think like a tester when I'm at the dinner table. So I really behave differently around her. That's the other secret.
Please make time for this question.
Okay.
Do you think the future AI, artificial intelligence, will be capable to take over testing? This is a good question.
It is a good question. No, AI cannot do that because testing requires responsibility, and AI is incapable of responsibility. Only humans are capable of responsibility. I think the way you should think about AI, and by the way, I just got a contract testing AI, so I'm very excited. I'm doing test strategy for an AI product for the first time in my career, and I'm rearing to go on this. I think the way to think about AI is think about it like it's a very precocious child. Imagine that you have an 8-year-old child that's eager to impress you, and it's sitting next to you. This child is looking at what you're looking at and says, "Oh, look at this! I found this." And oh, look at that, I found that. I think AI will be like that. It will help us identify problems. It will see things that we don't see, like a child would. But you don't ask the child to give you a judgment on have you tested enough, because the child doesn't have the understanding of the social order that is necessary. When I decide that I've tested enough, I'm putting myself in the place of my client. I'm understanding what their concerns are and what their needs are. And AIs can't do that. Let me put it this way. If you had an artificial intelligence that could do that, it would be just as flaky as people are. You know, someday when we achieve real general intelligence in an AI, it'll be, congratulations, you've just invented a sullen teenager who doesn't want to do anything that you tell it to do and is constantly worried about its appearance and self-worth. And now you have to do psychology on it for 20 years before it's going to be useful for anything. So I think that part of the fact that humans are chronically depressed, that we humans have all these emotional problems, I think that's all part of our intelligence. I think it's all a side effect of why our brains work so well. It's not like those emotions and the depression and moodiness that we have is some kind of extra thing that's like a virus that attacked us at some point 50,000 years ago when we had perfect brains, and then some kind of virus came along and gave us depression. I think that it's all a side effect of all of the little physical heuristics by which our brains work. And if we reproduce that in AI, then we're taking all of our human problems, and we're just going to see it in AI. Of course, you see some of that now because machine learning makes decisions all the time, and it can't explain why it made the decision. It can't be accountable. It just says, I just feel this way. I just feel that women aren't good at paying back loans. So I just told you not to give that woman a loan. And when you trace that back, you see, oh, all of these human biases have been put into a data set and then have been just given to an algorithm. And now it's just replaying our own biases back to us. That's all that machine learning does. All of the worst aspects of humanity just get amplified by AI. So no, I don't think we're going to see AI replacing testers. I do think that it will be an interesting and helpful assistant to us as we test. Yes. And I look forward to that.
Can I ask you again one more question?
Sure.
How do you decide you have tested enough? Let's take the example from earlier. You said that you're going to test an AI. When is going to be enough for that? Because AI can have so many applications and ramifications and so on.
Right. Well, there are a whole bunch of different models that that occupy my mind that get me to that decision. For instance, well, let me give you an analogy so that you'll understand it intuitively. When you go into a room, let's say a conference room at work, and if I were to say to you, I want you to search for Easter eggs in that conference room, because let's say some kids came in for Easter and we had a little Easter egg hunt for them. And now we have to clean up after the kids. Maybe they didn't find all the eggs that we cleverly hid in the conference room. If I asked you to search that conference room for eggs and you didn't know how many there were because we never kept count, you could come up pretty confidently with an idea of when to stop searching for the eggs. And that thought process is exactly the same thought process we use in testing. It's just that the product space is more complex than a conference room space, and bugs are harder to spot than Easter eggs. So you have to have a model of how would you recognize a bug if you find it? What is the space that you need to search? How do you know that you have searched it? Where are problems or Easter eggs likely to be? I mean, I'm not going to search above the ceiling tiles. No one's going to hide Easter eggs from kids above ceiling tiles. I mean, that would be like Premier League professional Easter egg hunts. You're not going to do that with kids. So think about just introspect on the different kinds of modeling that you do when you are searching for Easter eggs, and we can apply all of that to testing. So we've got to understand the complexity of the space, the complexity of the input space, the complexity of the output space, the different degrees of freedom, as statisticians say. We need to understand the phase space of the product, as physicists say, all the different states the thing can have. The more understanding we have about that, the more we go, uh-oh, there's more places for bugs to hide. But if the bugs that can hide there aren't very important, well, then we don't need to do very much testing. So the importance of the bugs comes into it. Also, something called opportunity cost comes into it. You have to ask yourself, what's the value of what I need to do after I do this testing? Maybe I need to get on and test something else that's also important. I can't stay here all day. So I've got the cost, I've got the opportunity cost, I have the value of the testing in terms of the risks associated with the bugs. I have the size of the space. I get understandings of all these things. I jiggle it around in my head, and I get a feel for where I am. And here's the last thing I do. I talk about it. I talk about it to my client. I talk about it to other testers. I talk about it to the developers until we all are nodding and saying, yeah, that's enough. I mean, we might have missed something, but that's enough. You want to get to the point where when you stop testing, ask yourself, if a bad bug appeared tomorrow in this product that I missed, will I feel that I had been stupid and reckless? Or will I feel that, hey, look, I did a good job testing. I did a reasonable job. Sure, I'll learn from this and I'll get even better. But I won't feel terrible if there's a bug in here because I am proud of the work that I did. I mean, that's to me the ultimate question I ask myself when I stop testing. Now, in any particular technology, we might be able to be more specific. We might be able, certain kinds of technologies are very data intensive, so we can model the data space. Some are very function intensive. We can model that. Sometimes we're testing things that involve lots of standard components, so we feel like we don't even really need to test at all. Sometimes it's a prototype, and we say it doesn't even matter if there's bugs in our prototype. So it all depends on those kinds of factors. Oh, we may be guided by standards as well. I've done some testing in the medical device space, and we had standards that we had to care about, and those standards gave us some guidance about how much was enough. But we never get all the guidance that we need. It comes down to all your understandings, your rich mental model of all these possibilities. And it's ultimately not up to you when you stop testing. You're going to make a recommendation. It's a business decision to stop testing, and the business is going to make this decision, not you. You can always do more testing, and they can always want you to do more testing. But I've been on projects where they wanted very little testing, and they were willing to accept huge risks. And I've been on projects where they gave me a huge bag of money, and they said, do the best testing you've ever done. Do every idea you can possibly think of, hire anyone, get any tool, because $1 billion rides on the answer to your testing. $1 billion, actually it was more than $1 billion of dollars. In 2002, I was on a special court case as a tester where many billions of dollars, it was the Microsoft antitrust remedies trial. And my work was fundamental to the outcome of the case. And they just said, here's a huge bunch of money. Just do anything you want to do that you can think of, because we have to, getting the right answer is the most important thing. But when I'm in a commercial environment, nobody ever gives me everything I want. Nobody ever throws money at me. In fact, it was very depressing on that project, I got to tell you, because I realized I will never make this much money ever again in my entire life. And that was almost 20 years ago, and I haven't been on a more lucrative project than that. So my depressing thought, has so far come true. So isn't that interesting? You've got court cases that will say keep testing until the last possible moment. You will have people who don't want you to test at all in the commercial world. Sometimes they don't even want a tester on the project. And then you have, most places are kind of in the middle. But ultimately, remember, it's a business decision. You make your case to the people who run the business, and then they decide what testing that they want. And if you think they don't have enough testing, then just warn them. Just write an email that says, I understand we have to stop testing. I get it. You got to run your business. You want to run this red light. And I'm just telling you, there's a danger when you run a red light that something's going to come and hit us as we're going through the red light. So I haven't checked for that. I don't know. Here's testing I didn't do that I think we should have done. And you understand that we have not done that. Now you may go make any decision you want, because it's up to you, because you run the business. So I will write emails like that if I feel it's necessary.
I was about to say, if you're paid by the hour, never stop.
Well, that's right. I mean, that's the other thing. If the budget goes on forever, I mean, why would I stop?
Thank you very much, James, for your time and for
All right.
this
Thanks for these
awesome
questions. They
presentation.
were a lot of fun. A lot of fun. It's fun
Thank you very
being here.
much, and we hope we will see you at the next PeakIT presentation.
Well, I will if I'm invited. Yes.
Yes, the
Thank you.
invitation goes on now.
All right. Bye-bye.
Bye. Thank you.